Good morning, everybody. My name is Kent Lidström. I'm going to be here talking to you about optics. So I'm going to repeat what Johan just said, but from a slightly different angle. I'm also, very much like Johan, a very young guy that's been in the industry for at least over 20 years. I'm working for Smart Optics today, and we are a Scandinavian manufacturer, and we develop and manufacture open optical line system, and we do sell that together with optics as well. So what I'm going to talk about here is the DWDM solutions in the metro and some aspects around that. I'm not going to talk as technical as Johan did related to the technology, more on our experience of how this works into your environment if you're going to run the optics in a router and switch, and how to relate to the open standards that are applicable now on the market. So the two topics that I will talk about here, which one? That one, I guess. Related to the 400 gig technology and what trends we see there, and what kind of challenges and opportunities you guys can benefit from when it comes to this technology. The second point is around disaggregation. Why is this popular? What does it mean? And most importantly, what kind of challenges and opportunities does it bring for you? Starting with the 400 gig side, what I will do here, I will talk about the pluggable 400 gig optics that are now coming out on the market. It is a very, I would say, exciting technology that will change the dynamic on optics and how you use optics in the metro and access networks. If we look at an open line system, some kind of transport network sitting in the middle there, it could be point-to-point, ROADM-based, I don't really care in this case. You can use the pluggable optics in two ways. One way is if I call it the traditional way, where you put pluggable optics into your transponder, muxponder, you get certain capabilities out of that. The typical form factor for that right now is CFP2. This is very applicable still for the 400 gig pluggable optics. However, this is not what I'm going to talk about. If you have specific questions about this, talk to your DWDM supplier and you will get more information of, say, technology, performance, and so on. What I will focus on is the IP over DWDM, where you plug in the 400 gig optics directly into your host environment, the switch and router. And our learnings so far and our experience, how this works, it is to some extent quite simple, but there are also a lot of challenges associated with it. Looking at it from a technology standpoint then, we have buzzwords on the market, 400ZR versus the 400ZR+. What does it mean? 400ZR is a very well-defined standard, standardized by OEF. It specifies all the aspects of the optical modules. It specifies it on the optical level. That means you are supposed to be able to take vendor A on one side, vendor B on one side, run traffic toward each other, and it should work. And it does. It is standardized on the electrical interface. That means if you've qualified in your router supplier A, you are supposed to be able to take supplier B's transceiver, plug into your router, and it should come up and it should be able to talk to it. And last but not least, it's also standardized on the register map. So all the information that you read from one module will also be presented in a different module. So that means you can basically commoditize the 400 gig optics. This really works well. So we've tested the OEF 400 gig on, I would say, all the major switch and router suppliers. Very successful results. There are some deviations. I mean, if you look at, for example, a Cisco portfolio, they have multiple platforms that support 400 gig, the pluggable optics, some does not. We, for example, tested a Nexus platform here this week, and the original software that was released did not support it. But then the latest patch that was released here just recently did support it. So there are a lot of improvements going on in the overall industry to support the different optics. But in general, this works quite well. If we then compare it to the 400ZR, what is that? Well, 400ZR is not a standard. People talk about it in different aspects. There are a number of different MSAs that are falling under the umbrella of 400ZR+. I point out a few of them here, the OpenXR that Johan just talked about. We have the Open ROADM, and we have the OpenZR+, initiative. All of those are in different, say, development cycles with different aspects and feature sets. There are also a number of proprietary versions of those that are not falling under an open initiative, but that can provide advantages for the network. When you use those, they are supposed to be able to work in many different applications. Everything from simple point-to-point, longer distances, rodent-based networks. There are some challenges associated with it now, day one. But if we look at the 400ZR Plus and our experience there, what we see is that it's clearly something that you need to have, say, implemented into the host system. It is only the OpenZR Plus that is GA today with optics that fits into a switching router, meaning the OSFP or SFP or QSFP DD form factor. There are CFP2s that fulfill the open ROADM spec, but no GA product today that fulfill the open ROADM spec on the DD form factor. They will come out later this year, but not yet. You cannot expect that if your router supplier have implemented support for OpenZR Plus from vendor A, that vendor B will work. So far, we have not been very successful there. You need to have say, host implementation for that particular supplier of the optics. So this is, of course, a challenge, but it's also an opportunity because this allows for innovation. Under the ZR Plus, you can actually add more benefits and add, if I call it, functionality that enhances your network performance. So there are pros and cons with everything, but this is one of the challenges around it. And if we look how those optics are supposed to work, I'm going to show you a table here. I'm not going to go through every detail, so don't worry. But if we look at the way one of those optics is working, is a 400 gig optics, they have a 12-byte area in the register map where they expose their own capability, called different application modes. On an OpenZR Plus, there are 14 different defined versions of say, capabilities. The first three, application mode 1, 2, and 3, they all belong to the OEF 400ZR standard. When you use them, it will work very well. The remaining ones, they are associated with the OpenZR Plus in this particular case, then they will work slightly differently. So this is what I mean when the implementation on the host side is very well defined. It is well defined for the first three. For the remaining application mode, it varies from supplier to supplier. The way this is supposed to work is that when you plug it in a switch and router, it reads the capability from the optics. And if the router supplier have implemented support for different application mode, the user gets an opportunity to configure the optics in the way that they want them to be configured. So it's a very smart way of doing it. I wish everyone followed the same standard, and it would be much easier, but that's always the problem with standards and deviating from standards. So that's, of course, the most common one, where you run it in a router, you have a 400 gig with CFEC. That's the original OEF-based standard. Another flavor that is also commonly used today in the switches and routers are the application mode 5, where you run it in 400 gig mode. Everything looks identical on the electrical side, but we use the OFEC instead of the CFEC. So we get significantly better optical performances. So now all of a sudden you can go in a fairly large, metro network with several hundred kilometers of transmission. So that's, of course, a very compelling application mode. Cisco, buying Acacia, they have a very good and mature implementation of this. But in general, what we've seen is that that mode is working quite well in the majority of the routers today. Some of the other modes that could also be of interest, running, for example, this one, 4 by 100 gig over a 400 gig line. Why is this of interest? The router has a 400 gig native interface. Why do you want to divide it into 4 by 100? Well, it provides an excellent migration plan. Because what you can do here now is that you can start to utilize the, if you build a network very similar to what Johan explained, you have 400 gig capable routers sitting in your head-end side or a central office, and you have 100 gig capable routers further out in your network. you can put a simple layer 1 max bonder and terminate that into a router port. That means the most expensive part of that max bonder using your QCP-DD on the line side, that will be the optics itself. Once you then upgrade your network in the access or further out to a 400 gig capable unit, then you just move that optics and put it into your router. So that migration plan becomes extremely compelling. But other reasons for it, if you go down in line rate, so in those different application modes here at the bottom, we go down to, for example, 300 gig on the line side using 3x100. That one, of course, allows better performance. I will show that a little bit later. So that's one of the reasons why those are, I would say, important. Very few of the router suppliers have implemented support for this today, so that's on their roadmap. But the only thing that I've seen that works properly, it's actually Cisco implementation of the later ones used in more max bonder modes. So, but I expect everyone else to follow going forward because I think this really makes a big difference for those used in over more advanced networks. There are some challenges around this. The standard today specifies -10 dBm as the TX power level. That means they will be very difficult to fit into a brownfield network. So in order to get them into a brownfield network, you need to have units with higher TX power. Those will come out and be GA end of this year, so we start to see an evolution toward optics that actually deviates from the standard, but in a good way, providing higher TX power so we can actually bridge longer distances and also fit them into more of a brownfield network. If we look at a different, say, market forecast for them, we see that the deployment expectation between coherent in, as a transponder, max bonder, proprietary version in the embedded version that Johan mentioned, versus IP over DWDM, they grow pretty much at the same rate. We will see in the end there later on, the expectation is to have about half in 2026. Expectation is about 500,000 deployed units of both types. So it is clearly a technology where the analysts expect a lot of growth. So very interesting technology. So that was my last slide around the 400 gig side. If we then look at the disaggregated part of the network, so this is then another important building blocks to put together an open line system running IP over DWDM. So what is disaggregated open optical solutions? Well, it depends a little bit who you ask. I will provide my view on it. If we look at the left side there, we have, if I call it a traditional way of building a network, you have a big chassis from one supplier. In that chassis, you slot in blades that has a particular use case. It can be an amplifier, a WSS. It only works in that particular chassis. The chassis uses, or the solution uses, proprietary data models and proprietary interfaces, talking to a management solution that is developed by the same manufacturer as the box. That is a traditional way of running it. Absolutely still a valid option. The disaggregated building concept is that you break apart the functionality in individual boxes. In this case, I draw it as pizza boxes. It could, of course, be different ways of doing it. But it could be, if we look at just the optical level, one box doing the amplification, one box doing WSS. So you can actually build the best of breed solution from different suppliers, but also other layers as well, like firewall boxes. It can be router switches, of course. The difference here is that they use open and standardized APIs. So you can and common data modules, typically Young-based modules. So you can integrate them into an open source network controller. This is kind of the view on what disaggregated open networking means. And what is it supposed to give you? If you do this correctly, and if you look at the hyperscale guy that was driving this, it's supposed to give you fast innovation. Basically, you can select the best of breed of the different components on the market and build a solution that is, say, tailored based on what is available on the market today. You do not have to wait for a specific slot-in blade from that particular vendor that you have been locked into. It is then supposed to give you cost savings. If you commoditize the hardware, you should have more competition and be able to drive down cost in your network. And if you have done this with open APIs and integrated solutions into it, the operational model are also supposed to be easier. We will also see there that you can then, as I mentioned before, you can cherry pick the boxes and the solutions and software with the best-in-class functionality. And it then provides you with a flexibility so you don't get into this vendor lock-in situation. If you've done it correctly, I put that at last, it's supposed to provide simplicity. So you have a SDN controller, an integrated environment where you can then put a box from any supplier, and through open APIs, you're supposed to be able to, say, read, configure, and manage this. Is it that easy? Well, today it's starting to become, I would say, quite easy, or at least possible, to deploy completely disaggregated networking solutions. It has been a challenge for everyone that does not have a large R&D team. The big hyperscale guys, not a problem. They have, Microsoft through a large software development team writing their own controller and do all of this. They have the leverage to get exactly the right specification from the hardware suppliers to accomplish this. For an operator without a large R&D department, this is going to be much more difficult. So today there are independent third-party software solutions coming out of the market that provides this. But it is still a challenge to get the management piece together. You got to really think through your overall solution before you go this route. That is one of the challenge. Another challenge is, of course, that there are a number of different open initiatives on the market. What I've done here is I've summarized four of the different open initiatives, kind of randomly, or initiatives that we are associated with somehow at least. They are all, as I say, working together to some extent, but they are in some areas also competing with each other. So taking those then, I've summarized this with my own kind of words now, so it might not be exactly what if you look into the standard, what they state. But if we look at the open road then, that initiative was originally founded or driven by AT&T. And now there is a large number of both vendors and operators that participate in this. They have specified down to the hardware specification level. They started with ROADMs. They've added transponders and muxponders on top of it. So they've actually specified both the hardware specification, but also the data models and the interfaces. They use Young-based data modules based on the open ROADM spec, and they use netconf as the management interface to discuss, talk to the network elements. Another initiative there that adds value into this optical segment is the telecom infra project, TIP. So they consist of several work groups. The one that is most important for the optical industry is the Open Optical and Packet Transport Initiative. They specify a number of different boxes. They specify interfaces, and they do a lot of interoperability testing. One really interesting part of that initiative that we are, relating to is the multi-vendor simulation tool. They have developed something that they call GMPY, where they can simulate OSNR and GSNR, meaning non-linear simulations, over multi-vendor networking. And it does it very efficiently with very high level of accuracy. So that's very, very important if you're going to build a multi-vendor solution that you are able to plan, simulate your network. So that one comes in handy there. OpenConfig is another initiative that was initially focused on developing, independent young models. Today, there are a little bit more to it. They have specifically worked on the layer 2 and layer 3 side in the past, but we start to see now some layer 0, layer 1 initiatives around that. Streaming telemetry has been an important part that's kind of been used for quite some time in layer 2, layer 3. We start to see those requirements now coming down to the layer 0, layer 1 devices as well, using gRPC or something like that, but with OpenConfig as one of the standardizing organizations. Another, of course, important open forum is the Optical Interworking Forum, the OIF. They are specifying the electrical, the optical, and the, whatever you call it, the interoperability on the actual hardware, so more on module level. They are the one that are specifying the 400ZR optics. They are also working on 800 gig and a 1.6 terabit pluggable optic specification that will then evolve over the next 5-6 years. So all of those you have to kind of relate to in order to be, an open networking provider. And you also, if you as an operator want to use disaggregated solutions built on this, you need to understand what kind of APIs the different boxes support, so you can build your solution together. So there are a lot of good things around this, but there are some challenges and things that you need to really pay attention to if you want to build a network this way. For example, when we built our new ROADM platform, we wanted to select an SDN controller based on those open initiatives. So we were looking to try to find, we did a pretty long evaluation of which route to go. We ended up selecting to go with the open ROADM, even if we don't like part of that standard. So they have standardized exactly what the hardware looked like. And basically, they have specified a Ferrari. That's completely overkill for a metro network in the Nordics. So what we have done is that we've built a hardware that deviates from the standard, but we use their control plane. Why do we do that? Well, if we just take an example here on what they have done. So in the open ROADM initiative, they have developed an open source SDN controller that they call Transport PC. It is developed actually from the operator side. So it's developers from primarily Orange and Telefonica that works on this to fulfill and create a controller based on that open ROADM specification. So this is, of course, a very, very good starting point, because then you get an open source controller that can manage, our ROADM boxes, but also other ROADM boxes. So it provides a good framework for it. This portion of the network, it actually just does the optical part of it. It provides the path calculation, power setting, etc. But it does not do any of the, it doesn't have any graphical user interface. So you have to add some kind of orchestration layer on top of it in order to make it a useful product. But this is one of the, things that you have to relate to when you select to go with a disaggregated building concept if you want an end-to-end solution across multi-vendors. If we then look at what this is going to end up with, if we look at the end game here, if we take a pluggable 400 gig optics and run it over a disaggregated open line system, what kind of performance do you expect to get from it? So this picture here tried to illustrate that. I've taken on the top table there, I've taken some of the different modulations format from the 400 Open ZR Plus standard and added the OSNR limits. We've been running a simulation on a ROADM-based network where we run it over a number of spans. Each span then, or each ROADM consists of 2 amplifiers, preamplifier, booster amplifier. So that's how we generate noise. And then we simulate that based on some generic criteria for the amplifier. And then we come up with a table there that shows what kind of OSNR you will have after each hop. Looking at that table, you will see that you will only be able to do, on the OF 400ZR, you will only be able to jump 2 hops. So this is without any margins or anything like this, raw calculations. 2 hops of 80 kilometer to be above the 26 dB OSNR. If we look on the other hand on the 400 gig, when you run it with OFEC instead, you can actually, when you have 23.4 dB OSNR to relate to, then you can actually go 5 hops across a network like this. And in a small metro network that typically looks something like this, 5, 6, 7 ROADM networks, that actually means that you get any-to-any connectivity in a network like this with 400 gig pluggables directly out of your routers. So it provides pretty good optical performance, and it really becomes useful. Once again, you may have challenges with a low TX power in brownfield networks. In greenfield, you can build to compensate for it, but in brownfield, it is still a challenge. But with the optics, and that's why I said I think it's an important thing that the routers can go down in line rate. You can see once you go down to like 300 gig, you can go, 10 hop plus. So then all of a sudden you get really, really good performance even on those pluggable optics. Not to the same extent as what you do if you build it into more of a, long-haul transponder, but still very good from an optical performance point of view. So that was my last slide. Thank you.
Thank you, Kent, for a very good wide-ranging overview. Any questions? We only need 5 minutes for questions, then you can have your lunch. Don't make me keep you in here. No questions? Steve, have you got a question? Oh, you've lucky escape, Steve.
Hello, Uffe Andersen from Aurelion. My question is, how much do you think you're going to disaggregate the line system? Do you see a real future where you buy a VSS from one vendor, then an EDFA from another, and then an OCM for a third, or do you kind of see that still staying together if you want to operate in a practical manner?
Well, I don't think anyone will do that. I don't think that it will go that far. I think maybe on a node-to-node interoperability level, but I think it's probably going to be more of a one area or one metro from one supplier, another metro from another supplier with a common management solution for it. That's what I at least see today on how far people are willing to go in disaggregation. So that's what I think will happen, or that's at least what we see today. And I don't see anyone really pushing for a deeper level of disaggregation.
Anyone else?
Thank you. Valeria here from Telia Denmark. I was wondering if you could comment a bit on the challenges with ZR Plus today, like output power, OSNR, anything that may require additional components beside the pluggable, if you want to go beyond those 5 ROADMs.
Yeah. There are a number of challenges. I mean, the TX power is, of course, an obvious one that really prohibit this to be used in existing networks. That will be, I say, dealt with already this year when the new type of optics comes out. The other part is, of course, the bandwidth. They are wider in bandwidth. You can run them in, like the question was before there, you can run them in a 75 gigahertz, networking. However, that's limited to point-to-point. Otherwise, you will start to get too much penalty. But if you have a 50 gigahertz DWDM network in the ground already, you are basically screwed for 400 gig. I mean, it's not going to work efficiently. On the pluggable optic side, you will be able to set the 200 gig down to in 16 QAM modulation mode in the next generation optics that come out later this year. And in that case, you will actually be able to run them at, say, 50 gigahertz spacing in 200 gig rate, but not on 400 gig rate. Then you have the tunable optical filter part of it. Right now, the current ones, they do not have any tunable optical filter. It doesn't really make any difference because they don't have any micro alpha, so you don't have any white noise. But the specification doesn't stipulate that you should have one. They have a very, very poor performance on the out-of-band OSNR. However, the reality that we've seen is way, way better. So we've tested it up to 32 channels without having any problems on, say, recognizing and detecting the signal. But based on specification, it really, really limits the possibility of using in any type of copper-based structure.
Last call for questions. Thank you very much, Kent.
Thank you. Oh, thank you.